Hi, in this video we will be seeing how we can perform a multiple time series forecasting using DeepAR. DeepAR is available part of open source Gluon TS package as well as DeepAR is available as cloud services in AWS Sagemaker. Now, DeepAR is a supervised learning algorithm for time series forecasting that uses recurrent neural network to produce both point in time as well as probabilistic forecast. When I say point in time, we typically build a model to say, okay, this is my forecast. And probabilistic is basically defining a confidence interval, like how confident I am with the forecast. Am I 95% confident or 80% confident? So it gives a confidence band, and that's what we call about probabilistic forecast. The best thing about DeepAR is it can work to create a single global model when you have multiple time series. Regularly, for each time series, you may create single model. Right, a typical example is weather forecasting. Now, when you are forecasting a weather for, say, like California, you define a time series model based on the past pattern of California. You cannot take a New York model and fit it into California. So you tend to create individual models for California, for New York, and think about like the number of countries across the world, or number of states, or number of zip codes across the world. You end up building individual models for each of those. Now, what DeepAR does is basically it tries to create a single global model on a large number of related time series, and it has a built-in special treatment where we can use this particular package where the time series magnitude varies very differently across each time series. Let's see how to do that. Like, we will go into the details of it. So what I'm doing is I'm very first installing MXNet. Underneath, to do deep learning, DeepAR runs MXNet. So we are installing Apache MXNet and we are installing Gluon TS. That's what we are doing. I'm going to run on a CPU version, but if you want GPU, I have commented on the top. You can just install this MXNet-CU101, or depending on a CUDA version, you can choose your package, right? And after that, I'm going to download an energy load data set. Basically, this has 390 energy load from it's basically 390 customers, right? So it has energy load or energy usage of 390 customers, and each customer is a different time series for us. So I'm going to talk about the data set. I'm just downloading it from the UCI machine learning repository. This is the path, and then I am unzipping the file, and finally I get this file called LD201 to 2014. This is the time series data that we have is from 2011 to 2014. So let me just quickly do an head of the file, and you can see basically first column is the date column. Basically, I have the data. The time is recorded every 15 minutes. Every 15 minutes, that's right. And this MT001, MT002, 003 are individual readings from houses. So this can be house 1, this can be house 2, this can be house 3 and house 4, and your readings for that. So let me put it into pandas so that we can see it better. For that, what I am doing is I am installing pandas, which will load the data. I'm having matplotlib to visualize the data. I'm using the DeepAR estimator package of Gluon TS, which we'll use for modeling, and the trainer object to set the training parameters or hyperparameters, the numpy object just to play around with the data. And then I will load this particular file into a pandas read CSV method. You can see it is like semicolon delimited. That's why I've given the separator as semicolon. And then the first column is a date column. So I'm telling take the index 0 column as the 0th index column as an index column. So pandas will use that column to index the data. And I'm telling that past date is true. So this is the first column is date. It will go and look across the date column and convert it to date data type. If you don't give this, it will convert to object data type. The advantage of giving a date data type over here is basically we can quickly do a slicing and dicing of data based on date ranges. Otherwise, you will not be able to do. And I'm just telling the decimal values are separated by comma. So in the case like 123.52, right? In this case, what happens if you see the file, it is written as 123, 52. The reason is the semicolon is given as comma. So I'm just telling, take the wherever there's a comma in an word, just take that as a decimal value, right? So let me run this and let's quickly see the output. Sorry. So it's getting loaded. After that, we will see the output and then we will start our modeling process. Before that, we will also do visualization of our data. So this is how our data looks like. If you see, like, we have the date column on the left, which is indexed over here, and the observation as every 15 minutes, as I told you. And on the top you have multiple time series for each household. So I have around 390 columns over here. If you see below, 370. So I have like around 140,000 rows and 370 columns. The data range is between like 2011 January 1st till 2015 January 1st. So it's almost till end of 2014. So we have 2011 to 2014 data. Right. Now, the very first thing I'm going to do is I am quickly going to visualize the output. Before that, I'm just seeing the column names, and you can see that this of the column names are M001 to 370, and we have 370 time series over here. The reason is why I call it a 370 time series, because say it's a household reading. Now, every household will have a different energy consumption. Some may have heavy appliances, some may not have heavy appliances, some may be home most of the time, some may be going to work and only coming during the night, some may come only during the weekend. So there are a lot of parameters that are different in each and every household. That's why I say it's every column here is an individual time series. So quickly to visualize, what I'm doing is I'm going to visualize 10 households. I'm just creating a loop over here from 0 to 10. I am just giving a subplots, that is five, arrange like 5 column and 2 rows. That's what I'm telling. I am taking the columns above. I am taking the first 10 columns. Like if you see, I'm doing a df dot columns of I, that it will take the 0 column, which is empty 001. It will take the first column, that is empty 002, up to empty 010. And I'm telling just visualize for 2 weeks, that is 01/12/2014 to 14/12/2014. Because we have a lot of data point, if you visualize all the data point, it will not it will basically not show any proper pattern, right? So I'm just taking 2 weeks of data and I am looping and visualizing it. So it's going to go to the data, it's going to create chart for it, so one shot. You can individually create also, but this kind of a handy function that I can use to quickly create charts. So let's go on the top and visualize this particular data over here. Right, if you see, this is how the data looks like. This is empty 001, and you can see this is how the time series pattern is. It's pretty kind of flat, right? Initially there's a spike and then it's kind of flat, but if you see the household 2, there are like ups and downs, and seems to be some kind of seasonality in the pattern, right? And if you see the household 3, again it's ups and down, but it's more flat. If you see here, there are like lows and highs. Maybe during the week, during the daytime there is less consumption, during the night time there is high consumption, right? So that is a peak and valley. And if you see here, this is what I told about multiple time series. Every time series is different. If I build one global model, right, it may not have the prediction capability to do fine grained forecasting of individual households. Maybe at an overall level it will do, but it may not have that capability. So that's why we need to create individual model for each of this time series, right? And that's become challenges when we have like a lot of customers. Say if we have a million customer, we need to have million time series. If you are retail, you may have millions of products, then you are creating many million time series, right? So we will see how we can do that in DeepAR pretty simply. So before going there, I'm going to quickly prepare the data. So what I'm doing is I'm taking that data frame, I am dropping the index. I don't need the index. For me, the order of data matters, but I don't need the index date over here. But I'm keeping the order and I'm transposing the data. .t is transpose the data. I'm going to convert my rows into columns. It will make me easy for the data preparation, and I will show you how it looks like. And then I am resetting back the index, because what will happen when I transpose the data, it's going to take the column on the top empty 001 as the index column, new index column. So I'm just dropping the index and resetting it. So now if you see the output, this is how my output looks like. Now in this case, my if you see on the top column is just 0 1 2 3 4 up to 370. My individual column name that I had previously became a big individual rows that I was at the column name became a column over here, empty 001, and the observations are transposed. Basically, my rows are converted to columns. So now I have, If you see, I have only 370 observations over here, but in the columns I have 14,257. Earlier it was 140,257 by 370. Now it's 370 by that number. So that's what the transport does. Now I have it. I need to create how what this target time series column, right? I need to tell my model treat every time series as a different model internally, right? It is going to create a global model, but it's going to learn that individual time series as well, and that's why we need to feed additional information to the model. So what I'm doing over here is I'm taking my index column. The index column is nothing but this column that has empty 001 002. I'm just taking that and I am converting into categorical, and I'm just converting into code. So rather than having a string value, I'm just having 0 to 370 number or 369 number over here. Just I'm converting the numeric value to column. That's what the values does. So if you see this particular output, instead of having the string value, it's going to have the numerical value of that, which I can feed to my model. And it has from 0 to 369. That is 370 time series, right? And again, my df input is the same over here. Whatever we saw, it's basically transposed value. Now I'm going to prepare my train data and test data. So what I'm telling is, take from the first column to 134,000 or close to 140,000 column as my training data set, and take the remaining from there as my test data set. So out of this 140,256 column, around like 140,000 close to that will be taken as training, and remaining around 257 odd will be taken as test data. So now not 257, it's around like 5,000 odd will be taken as test data. So if you see, like, this is how my data looks like. So it has around 134,998 columns. That is the time series value. It has like 134,998 observations in time intervals, and for test it has 5,258 time interval. So this is how my data train and test looks like. And it's very important, like in time series, like when we are splitting the train and test, we must make sure we don't shuffle the data. So typically, we by default in any machine learning model, we shuffle the data, right? Here you must not shuffle the data, because order of the data is very important to us, right? So now I have that. Now what I'm going to do is I'm going to define my model parameters. So the frequency of my data is 15 minutes. We saw the recording is done every 15 minutes. My training starting frame is basically 2011 January 1st, right? And the testing starting frame is nothing but 07/11/2014. That is based on the test observation that we split up. So my test data frame is starting from here, and my train data frame is starting from here, and I've given the frequency over here, and I'm telling my prediction length is 672. So basically, I have 15 minutes data, right? So when I say 15 minutes, I have 4 observations per hour. For 24 hours, I have around 96 observations, right? So I'm telling like 96 basically into 6 is basically 672. So I'm taking predict for 6 days of data, right? That's what I'm telling over here. So what I want to do is I need to predict future 6 days of data. That's the outcome I want to do. Now for that, what I am also doing is I'm going to define my estimator. I need to also define my context length. How much backward do I need to go to predict the forward values, right? And that's what I'm setting over here. In this case, I'm creating an estimator, that is a DeepAR estimator. I'm setting my frequency as 15 minutes on the top. The context length tells how much of data I need to forecast the X interval. So here again, I'm telling my context length is also 672. So take previous X days of data and predict future X days of data. In this case, take previous 672 instances of data, which is every 15 minutes, 672 observations every 15 minutes, and predict future 672 instances every 15 minutes. And that's what the prediction length tells, to predict how much in the future. And here I am adding something called use future static category true. And I'm telling cardinality is 1. So typically when we have a time series model, we will not only have numerical data, but we will also have categorical data. Now it becomes very challenging to handle categorical data. In our case, the only categorical data that we have is the household number 0 to 369. But you can have other categorical data in your model as well, right? You may have like is neighborhood is commercial or is residential for an electricity for an energy forecasting, right? So those are all category data. So you can use this feed static category variable over here to feed in additional categorical information. And for that, what I'm telling, like, it's just true. I will show you how to feed that. And in this case, my cardinality is only one. But sometimes when you're dealing with store and product in the retail, for one store might have hundreds of product, your cardinality will be higher at that time. You may have for 100 products, your cardinality is 100. Right? In this case, my cardinality is only one because I have only one line item per each household. And I am setting my model. I'm telling it's a LSTM model. The number of cells in each layer is 32, and I need two layers. I would say, like, you can increase it as your complex problem complexity increases. You can use 64 or 128 and then train the model. But for me to quickly complete this video, I'm just going to use an lower. I'm just going to use a lower value. I've given 32 and 2. And then what I'm telling is train for 5 epochs. Right. Again, like, if your data is very complex, very big, you need to train for higher number of epochs. Right. And to complete this quickly, I'm not going to take all the 370 household. I'm just going to take the first 7 household in this case. So I'm just going to take like MT001 to MT007. That's what I'm going to do over here. So now what I'm doing is this is how the list contains. It has values from 1 to 7. That's what it contains, right? So now next what I'm going to do is I am going to set my training and test data set, right? And for that, what I need to import from Gluon TS Commons list data set and the field name, right? So in the list data set, I am defining my target variable, my start training time, and then my feature static. I have given the category static feature as true. I have to define that as well. And how do I define that is by this method. In the case of start, I am just giving the start train which I define on the top directly, right? But this particular target and the feature static category, I'm going to pass it below, and this is how I pass it. So basically my train column, right, the DF train column that I created, data set I created, that is my actual data set. I am passing the 7 households which I want to train on. And then the TS code which I created to convert the household string name into numeric, I am passing the 0 to 7, and I'm just creating a reshape so that it has a one dimension on the back, right? This particular Gluon TS wants this data to be of a single dimension, or it can be multiple dimension also. It must match your input data set. Here I'm just reshaping it, and I'm setting frequency is basically 15 minutes, which I defined on the top. Similarly, for test, I'm doing the same thing, but I'm passing the test data set over here. So I will train with the top training data set, and I will use the test data set to predict future events. So I'm going to do some back testing, right? That's what I'm using the test data set for, and the same parameters I am passing. Right now, if I quickly want to see how my train data set is, I can just do a next of iteration, and you can see basically I have the timestamp starting this one, and then I have just an array of values. And basically, sorry, this is a train data set. So I have array of values, and basically the target values, whatever I have for the input data, right? It just gives you the information quickly. Now I'm going to take the train data set and train the value. I have created an estimator, which is nothing but the DeepAR estimator. I'm calling the train method, passing the train data set, and that will give me a predictor as output over here. So let me it's going to start training. It will take some time to train. What the category in this case does before we go there, right? The feature category. Now it will see the category. For each category, it's going to see the pattern of my time series and build an individual predictor over there internally. But what we finally get is a single predictor that we can deploy, but it can understand the data based on the future static category you are passing. And also you can pass real values. Say if you have multivariate time series, you want to give additional information to the model, you can. There is one more parameter called feature dynamic real. You can use that to pass the additional multivariate values. But here for each of this, it's going to learn the pattern, learn the time series pattern, and it's going to help us in prediction. Let this model train. It will take some time. Just now the first epoch I started. I have 5 epochs. Once it is complete, I will come back. But let's see, like, after this, how our model is predicting on unseen data, right? So I will kind of continue as soon as this training is done. So now the training is done and we have a trained predictor. You can see basically we trained for 5 epochs and the loss has been decreasing. Only in the last epoch, the loss slightly went higher than the previous epoch. But overall, this is how the model we have. It's better to have early stopping and everything incorporated. The trainer object that you saw on the top, maybe you can have early stopping to it and you can add other hyperparameters like learning rate and everything. But we just went with the default values over here. So if you see on the top in the DeepAR estimator that we defined, the trainer object over here, we just gave epoch, but you can give other parameters as well. So now that we have the predictor, let's see how good is our predictions with it. So what I'm going to do is I'm from Gluon TS evaluation backtest. I'm going to import make evaluation prediction package, which I'm going to use for predicting on the test data set that we created on the top. So I'm using the make evaluation prediction. I'm giving the test DS over here, the data set that we created on the top. You can have multiple time durations you can given at one star shot. Basically, if you want to do multiple back testing, say for the month of October, November, December, you can have or you can frame it all at one shot. But here just I'm using one time frame. I am passing the predictor that I trained on the top over here, and then I'm just telling number of samples is 100. So the output will be the forecasted value and the actual value is also that I'm taking, right? So once I have this, I am going to import this TQDM auto notebook from I'm going to import TQDM. It's just a handy package. You don't need it as well. You can directly plot your output. But to get the forecast and to get your basically actual timestamp, I am using it, right? That's what it does. So what I'm doing is I'm just converting this incoming values to a list object, the forecast into a list object, and that's what it does. It will assign to a TSS value, which is nothing but the time series value, and forecast is the prediction value. So it is just a handy function, but as I said, you don't need it. You can directly feed it into a graph as well. So it will run. If you see over here on the top, we didn't predict for all the 370 time series. We predicted only for 7. So that's why you can see over here, it's telling like 7 of 317 and it's done. It's not going to go and predict for everything because we have data in our categorical value only for 7 time series. Now this is done. Now what I'm going to do is I'm going to go and plot the output. To do that, what I have done is I have created a function over here. And in that function, I am telling plot the 80% confidence interval and 95% confidence interval. And the prediction length is nothing but my time I have given on the top around 672 or something like that, which I want to predict, right? And then I'm just defining a plot over here. I'm just giving some legends and everything, but it's a simple pandas plot that you will do. So let me run the function, and now I am going to iterate over the TQDM that I have defined on the top, right? It is just a quick handy function for iteration, as I said, and then I'm going to get the forecasted value in the particular index. Now the output I will have 7 index, right? Because we have 7 households that we are predicting. So it's going to iterate over there and then take that particular index value of the time series and forecast and going to call this plot function on the top. So once I run this one, it's going to plot the output. So if you see over here, this is how the output looks like. This is for one of the time series. Let me go to the top and then let's see everything. So as I said, like here in this case, every time series is different. So this is one of the time series. You can see the blue line is the observed line and the green line is over here, right? So basically, if you see the lower confidence interval, this is the light green is the 95% confidence interval. It still comes into the 95% confidence interval, but the model is not doing that great for this particular time series. Now, we need to maybe train for more epochs or maybe increase the complexity of the model, or we might have to give additional features to it, right? But in this case, this is the blue line that is the observed value, and the green line it's kind of in the 80% prediction confidence interval bucket again, right? And if you come down further, let's see like how some few other time series have been predicted. So this one it has done good, a decent one, right? The green is the dark green is the actual value, 80%, 90% observed value. It's almost like coming close to it. As I said, like maybe I need to train for a few more epochs, right? It's kind of here converging, and a few more epochs will do, which you can try it out. But what we saw over here is And in this case, it's even far better. The prediction and the observed value and the prediction are good. So what we saw here, rather than building individual models, we are taking the input time series, we are just preparing our data and then building a single global model at one shot that can learn varying within the time share multiple time series. Like that's what we have done. We also have an evaluator object where we can evaluate multiple models on how they perform. So in this case, I'm just using the gluon ts evaluator. I'm giving my evaluator contents as 10%, 50%, and 90%, and I'm just iterating through this and just printing the multiple matrices. So if you see this, it will give me for all the time series 0 to 6 that I have, what is the mean square error, what is the absolute error, and everything. And in this case, if you see the first, the second, and sixth, the last one that we saw, has done pretty well. The mean square error is pretty less. Even the second is okay. But if you see the third and fifth, the error is pretty high. So these two time series, maybe we need to see what is the problem. Either we need to add more additional variables, do multivariate analysis, or train for more epochs, or increase the complexity of a model. So it gets challenging in multiple time series. Like we cannot expect a single model to do all the wonders and magic. So there's a lot of back and forth iteration that we have to do, and we need to get it. But this is how you train a multiple time series using DeepAR. Thank you very much.